Good morning. All right, so we're going to finish up the exam review today. Again, there's only 5 more questions I want to go through, so hopefully we should have time to finish that up. Again, just make sure that if you haven't signed up for an exam time, I think I have everybody. There might still be 1 or 2 outstanding. Please make sure you do that so that I know when you're going to be in there taking the exam. That way, if you run into any technical issues or anything, I know that I'm available to help you with that, okay? If you have any questions after the review before you take your exam, I do still have student hours at my normal times this week, so feel free to drop in to ask me any questions you have there. Also, if you have questions about what you need on the final exam to maintain a certain grade or whatever, please let me know that, and I'll be happy to do that calculation for you, okay? Other than that, I think that's all I have in terms of announcements. Any questions, comments, concerns before we continue with the review today? All right, so if we take a look now at example 18, okay, so first thing we want to do here, we got to find all the zeros and then find all the factors, right? So what are we going to have to look at first to find all the zeros of this polynomial? All right, good. Find your P's and Q's, right? So if we look for the P values this time, what number are we looking at? Perfect. What are the factors of 135? Okay, so 1 and 135 for sure, right? So plus or minus 1, plus or minus 135. What other factors do we have? Okay, good. 27 and 5, so plus or minus 27, plus or minus 5. All right. Any other factors here? So I'm looking at the factors of the 135 here, right? So that's going to give us the P values, and 27 times 5 would give us the 135. So what other factors would give us 135? Okay, so 3 and 45. Good. And there should be one other set of factors here that would work. Good, 9 and 15, perfect. So plus or minus 9, plus or minus 15, right? So tons of options for P this time. Now let's look at the Q values. So what's Q going to give us? Just 1, right? So remember, leading coefficient this time is understood 1, so the Q values are just the plus or minus 1 this time. Now, once we have P's and Q's, then we have to do what? Okay, we can go to the graph, but before we do that, right, how do we find the actual values that we're going to be looking for? Divide P over Q, good. So in this case, though, when I do that, I'm just going to say this is the same as my P list, right, because I'm just dividing each one by that, so this is the same as P, right? Now we can go to the graph, right, take a look at which values might actually work, and then we'll test to see which ones do, right? So I'm going to graph this. So we've got x to the 5th minus 7x to the 4th cubed, 48x squared minus 153x plus 135. All right, so now looking at that graph, which values does it look like we might want to test this time? Okay, good. So -3 and +3. And is there anything special going on here that we have to keep in mind? Okay, good. It bounces at 3, which tells us what? Okay, good. It's got a multiplicity that has to be even in this case, right? So that tells us that +3 could happen twice, and so we might need to test that one 2 times. Okay, so just keep that in mind when we do our synthetic division now. All right, so I'm going to go back now. All right, so if we do the -3 first, what are the coefficients we're going to use this time? Are there any missing coefficients? Let's start there. Any zeros that I need to fill in? Not this time, right? But just keep that in mind. If you ever have any missing terms, always put zeros in their place. This time, though, I can just list them in order. So we're going to have +1, -7, +8, 48, -153, and 135. All right, first step with synthetic division, remember we're going to bring down that first term, so bring down the 1. Now we multiply. 1 times -3 should give us -3. This is always going to be addition here. -7 plus -3 is -10. -10 times -3 is +30. 8 plus 30 is 38. 38 times -3 should give us a -114. 48 plus a -114 is going to give us a -66. Multiply that by -3, that should give us +198. When we add that to -153, we should get 45. And now 45 times -3, remember that was one of our factors, 45 and 3, that is going to give us -135. And so we get a remainder of 0 here. Okay, so now in terms of our list of zeros, we know that -3 is one of those zeros. Any questions about that step? All right, so now we're going to test the +3. Same thing, bring down the 1 first. Then we're going to multiply. 1 times 3 is 3. -10 plus 3 should give us -7. -7 times 3 is a -21. 38 plus -121 should be 17. 17 times 3, 51. -66 plus 51 should give us a -15. And then -15 times 3 is -45. Remainder is 0. So 3 is one of our zeros. All right, now at that point, our exponent on our x is down to what? X cubed, good, right? So we started with x to the 5th, we've divided out 2 of our zeros, now we're down to x cubed. We can't do anything with an x cubed though, right, in terms of factoring or quadratic formula, anything like that. So we still need to go with one more 0. So what are we going to test next? 3 again, right? Since it bounced at 3, that's why that was important. We're going to go ahead and test +3 one more time. Bring down the 1. 1 times 3 is 3. -7 plus 3 is -4. -4 times 3, -12. 17 plus -12 is 5. And then 5 times 3 is +15. Remainder of 0. So now we know that 3 is a double root, right? So that one happens twice. All right, now we know what's left over then is going to be an x squared trinomial, right? So we know, let's talk about our factors. What's one of the factors going to be this time? Okay, good. X plus 3, that would give us the negative 3. What's another factor going to be? Perfect. X minus 3. And since that one happened twice, we can say that's squared. And now, what's this factor that's left over down here going to be? Perfect. X squared minus 4x plus 5. Okay. Now, if that factored, then you would just factor that, find your last two zeros, we'd be done. The problem here is the factors of 5 are 5 and 1. Both of them, though, would have to have the same sign to give us a positive 5. That's never going to give us a negative 4x in the middle. So what are we going to have to do now to find those last two zeros? Quadratic formula. Good. So that's our option here. So when we do quadratic formula, we're going to have x equals negative b. That's going to be the opposite of negative 4. So that becomes positive 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 1, times c, which is 5. All over 2 times a, 2 times 1. Any questions about the setup for the quadratic formula there? All right, so let's simplify what we have inside. If we square the negative 4, what's that going to give us? Good, so that becomes a positive 16. And if we multiply minus 4 times 1 times 5, what's that going to give us? Negative 20. Good. And then 2 times 1 is just 2. All right, now subtracting inside here, 16 minus 20 is just negative 4. So we get 4 plus or minus the square root of negative 4 all over 2. What's the square root of negative 4? 2i. Good. So remember, the square root of a negative gives us an I. The square root of 4 is 2. So now we have 4 plus or minus 2i all over 2. And if we simplify that now, what's that going to give us? You got it. 2 plus or minus I. Because we can divide 4 by 2, that gives us 2. 2i divided by 2 is just 1i, and then we have to remember the plus or minus. So now our last two zeros are going to be 2 plus I, 2 minus I. There is our list of all 5 zeros, and here is our factored form. If you want to write the factors using the i's, that's fine. As long as you get at least to here with that irreducible quadratic, I'm fine with that too. So either one of those will be fine in terms of the factored form, okay, but then your list of zeros would need to include all 5 of those zeros. Any questions on that one now? All right, 19 is the next one we're going to look at. All right, so for this rational function, we want to find all the intercepts, x and y, described in behavior ignore that. I just want to worry about the asymptotes, including vertical, horizontal, and slant. Okay, so if we can find the intercepts and all the asymptotes, that's the main things I'm looking for here. All right, so what should we do first with this rational function? Good. Always factor first to see if any of your factors cancel out. So let's look at the numerator. What can we do first to start factoring that? Good, right? We have a common factor of x, so I'm going to bring that out. That's going to leave us with 2x squared minus 5x minus 7. What about your denominator? How would we factor that? Good, so our factors there would be an x minus 2 and an x plus 1. All right, let's go back to the numerator. Can we factor the numerator any further than that? Okay, so if we look at the 2x squared minus 5x minus 7, let's see if we can come up with two factors that would give us that. You can keep your x. And let's see, can I come up with two factors that would give us 2x squared minus 5x minus 7? Okay, so start this way. What are the factors of 2x squared? Two x and x, right? So I'm going to start with a 2x and an x. What are the factors of 7? 1 and 7, right? That's my only option. Now, if I put the 7 down here, that's going to give us a 14x on the outside. That's going to be way too big, right? That's not going to give us the 5 that we want in the middle. So I'm going to put my 7 here instead, 1 down here. Now we get a 2x on the outside, a 7x on the inside. So if I can get the signs right, that would give us a negative 5x. What would our signs need to look like this time? Good. The negative would go with the 7. The positive would go with the 1. And that gives us a negative 7x plus 2x. And there's our negative 5x that we need in the middle. All right. Now that we have it factored, what are we going to do now? Good. We have a common factor of x plus 1, numerator, denominator. Those are going to cancel. And so that's the whole point of factoring first, is to see if we have any of those factors like that that are going to cancel out. Now let's start looking for our intercepts. How are we going to find intercepts here? Okay, good. So if you want to find, in this case, the x-intercept, we're going to let y equal 0, which means we're going to set what equal to 0 this time. If this is our y value, and we're setting that equal to 0, what would have to be equal to 0 to make the fraction equal 0? The top, right? The numerator needs to equal 0 in this case. So what I'm going to do is I'm going to take those two factors from the numerator and I'm going to set them equal to 0. So that's going to give us x equals 0 or 2x minus 7 equals 0. Now when we solve that, x equals 0 solved. What are we going to get for the other one when we solve that one? Good. Add the 7, divide by 2. That's going to give us positive 7 over 2. Okay, so those are the two x-intercepts now. Any questions on how I found those? Okay. How do we find y-intercept? Good. Set x equal to 0. Now it's up to you. Wherever you want to do that's fine. We could do it back in the original. We could do it in the factored form. I'll just substitute it into the factored form here. So we'll do 0 times 2 times 0 minus 7 all over 0 minus 2. But if we simplify all of that now, what's that going to give us? Okay, so up top now we have 0 times 2 times 0 minus 7. So what is the numerator going to be? 0, right? Because 0 times anything is 0. Over negative 2 now is just 0. Okay? All right, so now we know the y-intercept is 0. We have our x-intercepts. Now let's look for asymptotes. Start with vertical. How are we going to find vertical asymptotes? So what do we have to look at to find vertical asymptotes? Okay, so we actually don't have to go back to the original. We actually do want to look at the factored form after we've simplified it. But what part of that rational function are we looking at to find vertical asymptotes now? Denominator, good. So we're going to take the denominator now and we're going to set it equal to 0. Because we know in this case, that's where it would be undefined. That's where we're going to end up with an asymptote on our graph. So I'm going to say x minus 2 equals 0 this time, which is going to give us x equals what? Positive 2. Good. Now, that's the only vertical asymptote because the x plus 1 factor canceled out. So that's going to give us a hole in our graph. But the only asymptote now, vertical asymptote, is going to be at x equals 2. Any questions about how I got the vertical asymptote? All right. Horizontal. So how do we find horizontal asymptotes? Okay, so we have to look up here now at the original function, and we look at our degree in the numerator and the denominator, because we have rules here that tell us how many or what type of horizontal asymptote we're going to have. If the degree in the numerator is bigger than the degree in the denominator, like it is here, what does that tell us about horizontal asymptotes? Okay, that's right. There's not going to be a horizontal asymptote, and we're going to have to look for a slant asymptote instead. Okay. Remember, if those had been the same degree, then you would divide the leading coefficients. If the degree in the numerator is smaller than the degree in the denominator, that's when we would say it's y equals 0. Okay, so those are your three options. This time, the degree in the numerator is bigger than the degree in the denominator. Automatically, no horizontal asymptote. Okay, but like you said, that means there is a slant. How do we find the slant asymptote now? Long division, good. So I'm going to take the bottom here, put it on the outside. Top goes on the inside. Okay, and just like with synthetic division, if you're missing any terms, just make sure you put a 0 there so everything lines up. All right, what's our first step here for our long division? Good, so we take the 2x cubed. We're going to divide it by the x squared on the outside, and that's going to give us what? Good, 2x. That goes up here now. Now we multiply 2x times x squared, 2x cubed. 2x times negative x is a negative 2x squared. 2x times negative 2 is a minus 4x. Now what do we do with that? Subtract. Good. So make sure you group it all together. Subtract everything we've got there. 2x cubed minus 2x cubed is going to cancel. That should always happen. Negative 5x squared minus a negative 2x squared. Remember, that's going to become addition. So this is negative 3x squared. Negative 7x minus a negative 4x. Again, that turns into addition. This becomes a negative 3x. Any questions up to that point? Okay, what's our next step? Good. So make sure in this case it's the negative 3x squared, right? That's what we're dividing this time. So if we take the negative 3x squared, divide that by the x squared, what are we going to get? Just negative 3. Good. We get a minus 3 up here. Distribute that. We're going to get negative 3x squared plus 3x and plus 6. And just like before, we're going to subtract that. So just group all that together. Negative 3x squared minus a negative 3x squared, that becomes addition and cancels. Negative 3x minus 3x is going to give us what? Good. Negative 6x. And then technically we could have put a 0 here to bring that down. So now we have 0 minus 6 is going to give us a negative 6. Now, can we go any further? No. Negative 6x is not divisible by x squared. We're done. What is our slant asymptote going to be then? Perfect. So y equals whatever the quotient was. In this case, that's 2x minus 3. We ignore the remainder completely, right? So all we care about is the quotient here. That's going to give us our slant. Any questions on that one now? And again, on a question like that, that's all I'm looking for. Can you simplify the rational expression? Can you find the x and y intercepts? And can you find all the asymptotes? All right, so next one we're going to look at, we're going to skip all the way to 29. So now we're in the exponential stuff. All right, so the count in a culture of bacteria is 900 after 2 hours and 112,500 after 5 hours. We need to find the function that's going to model the number of bacteria after T hours. All right, so how are we going to start this one? Okay, good. So we've got to set up two functions, right? Because we've got two kind of scenarios here that we're working with. And then we're going to set up a proportion and divide them. Now, the formula we're going to use, remember, is going to be N of T equals N sub 0, that's our initial population, times E to the RT, where R is your growth rate, T is your time. So if we look at this first one here, what's that equation going to look like for just the first part of this? So what information do we know? Good, right? So we know 900 is N of T, so that's our population after 2 hours. We don't know the initial population, so that's still going to be N sub 0. Our E is always E. We don't know the growth rate, so that's R, and our time is 2 hours, so times 2. Right, now, we know the exact same information about this other one now, right? We know the N of T and we know the time, so I'm just going to put 112,500 equals N sub 0, E to the R times 5. And like you said, now we can set up that proportion. We can divide these. So now if I divide that, 112,500 divided by 900 on the left should give us 125. What are we going to get when we divide the right-hand side? Okay, we're going to get E to the 3R power, right? So the N sub 0's cancel. Then we're going to subtract exponents when we divide here. So we have a 5R minus a 2R. So we're going to get E to the 3R. Now, at that point, since we've canceled out N sub 0, now we can actually solve for R. So what are we going to have to do to both sides to get R by itself? Natural log, perfect. So take the natural log of 125. And then if we take the natural log of E to the 3R, what's that going to give us on the right-hand side? Good, perfect, 3R. So we get natural log 125 equals 3R. And then we can do what? Divide by 3. So now we know our growth rate is natural log of 125 divided by 3. Now we have the R value. Once we know the R value, now we can go back and find N sub 0, and then we'll know what we need for our function. So it's up to you. I'm going to use the smaller values here, so I'm going to go with the 900. So we'll say 900 equals N sub 0, E. Our exponent now becomes natural log of 125 over 3 times 2. And at that point, to get N sub 0 by itself, we can actually just divide by all of that stuff we have down there. So if you want to put it in the calculator and get a decimal and just keep as many decimal places as you can and then divide, that's fine. Or you can just put all of that right in the calculator as is. We're just dividing by E to the natural log of 125 over 3 times 2 on both sides. Now, if you do that, just be very, very careful how you group things. The 2 needs to be in the exponent with everything else. So if you even wanted to write that as 2 natural log of 125 over 3, you could do that. And just make sure, again, all of that's in the exponent of the e when you do your division. Now, if we do that, what are we going to get? Perfect. That should give us 36 equals n sub 0. And again, you could have just done e to that power, gotten the decimal, and then done 900 divided by that decimal. You'll get the same thing. Right? So either way you want to do it's fine. Okay, so now that we know the r value and we know the n sub 0, now we can write our function. So we have n of t equals 36 times e to the natural log of 125 over 3 times t. Any questions about any of the steps to get to that function now? Okay. Now, when does the culture contain 2,000 bacteria? How are we going to find that? Good. Set that function that we just found equal to 2,000, solve for t. So we're going to have 2,000 equals 36 times e to the natural log 125 over 3 times t. What are we going to have to do first to get t by itself here? Good. Divide by the 36. Okay, so if we do that now, simplifying that is going to give us 500 over 9. I'm just going to keep that because the decimal would be a repeating decimal, equals e to the natural log 125 over 3 times t. Now we can do what? Take your natural log. Good. So we have natural log 500 over 9. Taking the natural log over here, remember, is just going to give us what's in the exponent. So now we have natural log of 125 over 3 times t. And so then our last step, we just need to divide to get t by itself here. So what we're going to end up with is natural log of 500 over 9 all over the natural log of 125 over 3 equals t. And then you could put that in the calculator and get a decimal, right? Because it probably makes more sense to get your time as a decimal here. So what would that give us? Just rounded to 2 decimal places is fine. Perfect, 2.50. And what are the units going to be on our time here? That's going to be in hours. Good. So this would be our time in hours, and this would be our function for part A. Okay. Any questions on either part of that one now? The 500 over 9. So when I divided, 2,000 over 36, and I simplified that, 4 goes into both of those. So 4 goes into 2,500 times, 4 goes into 36 9 times. So I was just simplifying that fraction when I divided. Any other questions there? All right, so the next one I'm going to look at is 31. Now we're in our systems. Okay, so we want to solve this algebraically. All right, now notice here that our second equation is already just in terms of x and z. So that's probably going to be useful to us when we actually solve this. Okay? If you didn't have that, then it really wouldn't matter what variable you eliminate first, right? But in this case, what variable do we probably want to eliminate? So not x, right? Because our second equation is in terms of x and z already. So if we eliminate y, then we'll have two equations that are just in terms of x and z, right? So that's why in this case, since y is already eliminated from the second equation, we can just work with the other two and try to eliminate y. How would we eliminate y using the first and third equations now? Good. So we need to multiply the top equation here by a -2. That way we get a -2y to cancel out with the +2y at the bottom. So now we're going to have -2x minus 2y minus 4z equals -12. Keep your bottom equation the same. X plus 2y plus 3z equals 9. Now we add. So what's that going to give us when we add those together? Good. So we get a -x, we get a -z, and then that's going to be a -3 over here. Okay. So now we have this equation that only has x and z. We have our second equation that only has x and z. So now what could we do next? Good. If we multiply this new one by 2, that'll give us a -2x, which would cancel out the 2x in the other one. So now I'm going to have -2x minus 2z equals -6. And match that up with the second equation, 2x plus 5z equals 12. And now I'm going to add those two equations together. When we do that, what's that going to give us? Good. 3z equals 6, which means that z is equal to what this time? +2. Good. Any questions up to that point? Okay, now that we have our z value, now we can do what? Okay, good. Plug it in somewhere. So where are we going to plug it in so that we can find the value of another variable? That second equation works, right? So the 2x plus 5z, so we'll go with that. So we've got 2x plus 5 times 2 equals 12. All right, so I'm going to go ahead and solve this. So we got 2x plus 10 equals 12. Subtract your 10, 2x equals 2. Divide by 2, x equals 1. Okay, so now we know what z is equal to, we know what x is equal to, so now we can do what? All right, good. The first equation is probably the easiest to work with here, so we'll do 1 plus y plus 2 times 2 equals 6. 2 times 2 is 4, plus 1 is 5, so we're going to have y equals, y plus 5 equals 6. And then when we subtract the 5, y equals 1. Now that we know all three variables, now we just write them as an order triple. X comes first, so 1, y is next, that's also 1, and then z is 2. This would be the solution to that system. Now, remember, if you have a graphing calculator, you can use matrices to check this answer. I need to see all the work, right, because it does say algebraically here. Okay, but if you want to check yourself using matrices, that's perfectly fine. Just remember, this second equation is going to have a 0y, so just make sure you have a 0 in your matrix for the y term in that second equation. Okay? Any questions on that one? All right. Last one. All right, so let's see if we can get through this one, at least get the setup of it, right? Because then you can solve it however you want. We've got a piggy bank that contains 50 coins, all of them nickels, dimes, or quarters. The total value is $5.55. We know there's twice as many nickels as quarters, and we want to know how many types or how many of each type are there. All right, so what's the first thing we should do here? Okay, good. So what variables do you want to use this time? Okay, X, Y, and Z is fine. So X, Y, Z. I'm just going to go in order here. We'll say X is our nickels, Y is our dimes, and Z is our quarters. You could also just use N, D, and Q if you wanted to, right? And that way you kind of remember which one's which, okay? But X, Y, and Z works too. Now, if that's the case, let's think about the information we know. What's one of our equations going to have to be this time? Good. We know there's 50 total coins. So we know the number of nickels plus the number of dimes plus the number of quarters should equal 50. Right. What's another equation going to look like here? Okay, so we know there's twice as many nickels as quarters, right? So we know the number of nickels needs to be twice the number of quarters. Good. All right, now we have three variables. We need three equations. What's that third equation going to look like? Good, right? So 0.05, that's the value of a nickel, 5 cents, times the number of nickels, plus a dime is worth 10 cents, right? So 0.10 or just 0.1 works, times y, and then 25 cents is the value of a quarter, so 0.25 times the number of quarters should give us our total value of $5.55. And like I said, at that point, you can solve it however you want. If you want to use matrices, just make sure you move the 2z over. So we have x, 0y, minus 2z equals 0 for that one. Then we have all of our variables lined up. We can just enter our matrix that way. And when you do that, since we're out of time, I'm just going to give you the solution to this one. This should give us x equals 22 nickels. Y is 17 dimes. And z equals 11 quarters. Okay. And so just for your benefit too, let's say, for instance, you had messed up the second equation and put z equals 2x, right, which is a common mistake. If you worked it out, you're going to get weird decimals. I would never do that to you in terms of the number of nickels, number of dimes, and number of quarters, right? You should get whole numbers for these. Okay, so if that happens, go back and check your equations, okay, because this should come out as a pretty nice answer for this one, okay? All right, any questions at all now? All right, so like I told you last week, I'll say it again. It's been a pleasure this semester. Hopefully I'll get a chance maybe in the future to teach each of you again. Good luck on your exam and any other exams you're taking this week. And I will talk later. Have a great day.